Guys, welcome to Telecom Academy, a channel that affords you the opportunity to learn study at your own time, place, and pace. This time, it's me coming up with electrical engineering technology, that is Superposition Theorem. If you are new to the channel, don't forget to like, comment, subscribe, and also to share after enjoying. Let us go. If this is your first time to visit Telecom Academy, guys, after enjoying, after benefiting, don't forget to like, comment, subscribe, and even to share. It's Motion Marufu bringing you convenience to your doorstep, this time with DC Superposition Theorem. Let us enjoy it. After going through this presentation, you should be able to just 3 objectives. And this video, I don't know, it is going to be one of our shortest videos in EET with just 14 slides. The first objective, you must be able to apply superposition theorem to circuit analysis, which means that you must be able to find current and voltage using superposition theorem. And the second objective, you must be able to state the superposition theorem. Then you must be able to list the steps in applying the theorem. Just 3, and as usual, guys, we have got my assurance that you'll be able to do 1, 2, 3 after this very short presentation. Introduction. And guys, superposition is one of the most powerful tools in electrical engineering technology or circuit theory, and it has got wide applications. In general, it can be used in the following applications: to analyze networks that have got 2 or more sources that are not in series or in parallel, which means it's a series parallel combination. And in analyzing such networks, superposition theorem enables the effect of each voltage or current source to be analyzed independently, with the total result of each source being the algebraic sum of each source, so that you find the effective effect of the whole circuit. So it is very, very important, and you'll be able to use it before even the end of this video presentation. Superposition theorem states that the current through or voltage across any element of a network is equal to the algebraic sum of the currents or voltages produced independently by each source. Guys, one of the objectives says must be able to state the superposition theorem, and this is it. The current through or the voltage across any element of a network is equal to the algebraic sum of the currents or voltages are produced independently by each source. This statement shows that each source is analyzed independently. That is, we consider the effect of each source independently of the other sources. What this means is it allows us to find a solution for current or voltage using one source at a time. And once we find the voltage or current due to one source, then we find the algebraic sum of the effects of each source. If you are to consider the effects of each source, it means that the other sources must be removed. And how do we do that? We replace the current source with an open circuit and the voltage source with a short circuit, or we'll just leave its internal resistance if it is given. Hence the statement: when removing a voltage source from the circuit diagram, we replace it with a short circuit, and a short circuit has got 0 ohms. And if there is any internal resistance, it must leave it, or it must remain in the particular network. So guys, you must be able to state this, and also to know what steps do you take when you want to consider each source effects. More on superposition theorem. Guys, a recap: we know that an ideal voltage source has a 0 internal resistance, while an ideal current source has got an infinite internal resistance. And we are saying non-ideal sources are replaced with their internal resistances, which means that RS has to be included for a voltage source as well as for a current sources, and we'll be considering practical sources. And Please take note, you can also state superposition theorem as the current or voltage in any given branch of a multiple source linear circuit can be found by determining the current or voltage in that particular branch produced by each source acting independently, while all other sources are replaced by their internal resistances. How do you find the total current or voltage? It is found by the algebraic sum of the responses in that circuit. And this means that if a current due to V1 is 10 and a current due to V2 is -1, and also current due to V3 is 6, you have to add the 3. Let's look at the critical steps that are followed in or when you are analyzing a circuit using superposition theorem. Number 1, you leave one voltage or current source at a time in the circuit and you replace all the other sources by their internal resistances. And for ideal sources, a short circuit represents an internal resistance, and we know that an open circuit represents an infinite resistance. Guys, take note of this first step. It is very, very important. One of the objectives says you must be able to list the steps that are followed when you are analyzing a circuit using superposition theorem. We've covered the first step and we are now proceeding to the next step, and it says you now determine the effect of each current alone, or of each source alone. Determine the particular current or voltage due to one source in the circuit. Then number 3, you do that for each source or for the next voltage or current in the source until you finish all the sources in a particular circuit. Then the last step is you take the algebraic sum of the effect of each source and you are done. And we'll be doing that in this video presentation. So take note of the steps and you must be able to list them. How do you remove a current source from the circuit? You replace it with an open circuit, because it means that current will not flow. Therefore, please take note, when removing a current source from a circuit, replace it by an open circuit. This has been boldened so that you understand the significance. An internal resistance associated with the source must remain in the network, which means we are analyzing real or practical sources. Then removing a voltage source and a current source to permit the application of the superposition theorem. And we are saying, since the effect of each source will be determined independently, it means the number of networks to be analyzed will be equal to the number of sources. Let's have a look at this example, and we are saying we've got a source of internal resistance Rint, and we are replacing this voltage source with its internal resistance. So we are going to put a short circuit where the voltage source was, but please take note, its internal resistance must remain. If it does not have the internal resistance, it means that it will only be a short circuit. We are now removing a current source from the network. So what do? We replace it with an open circuit, but please take note that its internal resistance must be left. So this is how you replace a voltage source as well as a current source. So easy. As I said, we first consider the effect of each source, and we are saying when the effect of each source has been determined, we are going to have currents that will be in the same direction, and for those they are added. For currents in opposite directions, they are subtracted, and we find the algebraic sum. When we add positive and negative, we say we are finding the algebraic sum, and the total result is the direction of the larger sum. Please take note that we did this when we did voltage sources and current sources in series and in a parallel, and the magnitude or the size of current or voltage is the difference of the two. And we are saying similarly, if a particular voltage of a network is to be determined, we also consider the effect of each source, and after finding the effect of each source, we add voltage voltage with the same polarity, and those with opposite polarity are subtracted. And this is what we call finding the algebraic sum. And what will be our total result? The total result is the polarity of the larger sum, and the magnitude is the difference. Guys, take note of the explanation. It is important, though we covered it when we did voltage and current sources. Worked examples will clear all the gray areas. Don't worry, don't be anxious. For tomorrow will be anxious for itself. We are now going to analyze some circuits using superposition theorem. This is our circuit diagram on figure A, and we've got two sources, 36-volt source and a 9 volt source, and we are going to analyze each source independently. And we'll start with the voltage source, and we are going to replace 9 current source with an open circuit. So it means that no current is going to go via this open circuit. So it means that R1 and R2 are two resistors connected in series. So how do we find the effect due to 36-volt? We simply divide voltage by the total resistance. So that's 36 divided by 18, and we've designated the effect as I2 prime, and I2 is the current through R2, and this is what we are being asked to find by the question. Determine the current through resistor R2. So due to 36 volt source is 2 amps, we are now going to find I2 due to 9 amp current source, and what we do, we replace the 36 volt source with a short circuit. These two resistors are now in parallel. And how do we find the current flowing through R2? We use the current divider rule. That's 12 times 9 divided by 18, and this is going to give you 6 amps. This is going in this direction, and we've designated as I2 prime, and I2 prime is also going in the downward direction, so we are going to add the 2. So I2 is equal to I2 prime plus I2 prime. That's 2 plus 6, and this gives us 8 amps as the current flowing through resistor R2. I hope guys you have enjoyed it on your own, then you won't have any challenges in your examination. Another analysis of a circuit using superposition theorem. This time we are being asked to find the current through R2, and we are going to consider the effect of each source alone. And we will start with E1. And what do we do to E2? We replace it with a short circuit. And if we replace this with a short circuit, it means that this and this R2 and R3 will be in parallel, and their effect and their total or effective resistance will be 12 times 4 divided by 16, and you add that to 24 like what is shown. So if you do that, you discover that the total resistance will be 27 ohms. Then how do you find a current? Current is voltage divided by resistance. So it will be 54 divided by 27 ohms, and that is going to give us 2 amps. So our 2 amps is the supply current from the 54 volt source. So we now want to find the current through the R2 resistor, and we are going to use the current divider rule. We use this resistor 4 times the input current of 2 amps divided by the sum of the two resistors, which is 16. So we are going to get 0.5 amps, and we have designated it as I2 prime. We are now going to consider the effect of 48 volts source, and we are going to replace this with a short circuit, and these two resistors are going to be in parallel, and the total parallel combination is going to be added to the 4 ohm resistor, and your total resistance is going to be 12 ohms. To find your total current, you divide 48 by 12, you get 4 amps. To find the current flowing through R2, which is I2, we are going to designate it as I2 prime. So we are going to say this resistor 24 times the input current of 4 amps divided by the total resistance of the parallel combination, which is 24 plus 12, and this gives you 36. So I2 prime is 2.67. This is going in the please take note that this is our positive, so this current is going in the upward direction, and it means that we are going to subtract the 2 because the current due to E1 goes in this direction. And what do? We simply say 2.67 minus 0.5, and the current flowing through R2 is 2.17 amps. Guys, no problem. This is very simple. You consider each source alone and replace the other source with a short circuit in this case. Our last problem on analyzing circuit using superposition theorem, and this time, guys, we've got three sources. You must be able to analyze a circuit with three sources, up to three sources. We've got E1 and a current source of 3 amps and E2 of 6 volts, and we are going to consider, as usual, the effect of each source independently of all the other sources. And we are being asked to find the current through the 2 ohm resistor, and this is our 2 ohm resistor. So we are going to analyze the effect of each source alone, and we'll start with the 4 volt source. So it means that we are going to replace this with an open circuit and this with a short circuit, and we are going to have a circuit like this. This is a series circuit. No current will flow through this open circuit. So the current which we have designated as I prime 1 is 12 divided by 6. That's 2 amps. So I prime is equal to 2 amps. Since the two resistors are in series when the current source is replaced by an open circuit and E2 replaced by a short circuit. Let's proceed to the next step, or to the analysis of the other source. We are not yet done. We are still there. We now want to analyze the effect of the 6 volt source. And how do you proceed? You replace this with a short circuit and this with an open circuit. So our current is going to flow in this direction, and that current we have designated it as I prime, and it is found by dividing 6 divided by the sum of the two. That's 6 divided by 6. It gives us 1 amp. We are done with the second source. We are now proceeding to the third source, that is the current source. And we are going to replace E2 with a short circuit, E1 with a short circuit, and this is a parallel circuit. Current going in this direction, we have designated it as I prime. And how do we find it? We say 4 times the input current divided by the sum of the parallel combination. That's 4 times 3 amps divided by 4 plus 2, that's 6. So this is going to give us 2 amps. So we have got 2 currents in the same direction. That's I prime and I prime, and I prime is in the opposite direction, that is in the upward direction. So we're going to find the algebraic sum of the 3 currents, and 1 amp plus 2 amps minus 2 amps, we are going to get 1 amp. Guys, we are done. I hope insofar as the 3 objectives are concerned, you are able to state superposition theorem, you are able to list the steps, and you are also able to solve circuit theory problems using superposition theorem. Sometimes you are not told explicitly to use superposition theorem. It is up to you to find the most applicable DC network theorem to use. Guys, we are done insofar as DC superposition theorem is concerned. We are done, and I hope you are now able to state superposition theorem, to list the 5 steps, and also to solve circuit theory problems using the theorem. Until we meet again, guys, enjoy yourself. If you have got any DC network problem that you are finding it challenging to solve, or that you are failing to articulate, get in touch with me via the YouTube channel comments, and also on my WhatsApp number, or even my email, and I will do it for you. Guys, if you haven't subscribed, don't forget to hit the button. Also, don't forget to like, to comment, and also to share this video so that others can also benefit from the expertise. Until then, guys, enjoy yourself. And our next DC network theorem is Thevenin's theorem, and I hope you are going to enjoy